Hello everyone, good evening. So we are going to be talking about the OSI model and the network protocol, topologies rather. OSI model and the network topologies. So let's get to it. So what's our objective for the class? Understanding the basic concept of the OSI model and the network topologies, describe different layers of the OSI model and their functions, and identify the different types of network topologies and their advantages and disadvantages. So let's get to it. The OSI model. So OSI model stands for Open System Interconnection sorry, Open System Interconnection Model. So basically, it is a conceptual framework that describes how data communicates over the internet. So basically, it's a theoretical, let's say assumption, or a theoretical way that we can describe how data communicates over the internet. And this was developed by an organization called the International Organization for Standardization, that's the ISO, in the 1980s, right? So I know the last class we talked about IANA. So when it comes to computers, networking, there are organizations that are in charge of producing standards, because everybody will end up doing what they want to do. But we have to produce standards by which every device can be able to communicate with one another. We have to produce standards that will set as our landmark on how things are supposed to be done. So this organization called International Organization of Standardization, ISO, created the OSI model in the 1980s, and it has been adopted as the standard model for understanding network communication. So basically, once again, this is a theoretical concept or a theoretical framework, basically. So it just gives you an understanding on how network works. It divides the complex process of network communication into 7 distinct layers. Each layer is responsible for a specific function, and these layers rather ensures that data is transmitted reliable and efficiently between devices on a network. So let's get to it. So this is the OSI layer, diagram for the OSI layer. So you have on top the layer 7, we have the application layer. Then we have layer 6, presentation layer, layer 5, session layer, layer 4, transport layer, layer 3, network layer, layer 2, data link layer, and layer 1, physical layer. Now you can see that from the client side, it's going from up down. That is, client is more of like a user or the end product, the end device. So it's going from application layer all the way to physical layer. And on the server side, like the web servers and the rest, it's going from the physical layer to the application layer. So I need to know that the layers are down and up, you understand? So it can flow in any direction. It can go from application all the way to physical layer, and it can go from the physical layer all the way up to the application layer. Alright, so let's dive in. So we're talking about the application layer. So the application layer is the sole layer that interacts directly with user data. So this is the only layer that communicates with, that the user can communicate with per se. So software applications such as the web browser and the email client depend on application layer to initiate communication. However, it is important to clarify that the client software applications are not part of the application layers. But instead, the application layer is responsible for the protocol and the data manipulation that the software relies on to present meaningful data to the user. So let's give an explanation. Let's say, for example, now you want to um, send an email from yourself to your boss, right? The application layer handles the protocols, things like the SMTP protocol that you can be able to use to send that email from yourself to your boss, right? So the software, that is your Gmail or your Outlook or your Yahoo Mail, is not part of the application layer. Get it? Not part of the application layer, right? What is the application layer now? Is the SMTP server that handles the sending of mail protocol. The same way with web applications, right? If you go to your web browser is not the application layer. What is the application layer? Is the SMTP, which is the web traffic protocol. But from the image here, it says the website will request content from the application layer, and the application later requests the content in the requested format. I hope we're good. Then the next one we have is the presentation layer, which is the sixth layer of the OSI model, and it's responsible for preparing data so that it can be used by the application layer. So the presentation layer prepares the data so that the application layer can make use of it. This includes translating the data into syntax that the receiving device can understand, encrypting and decrypting the data, and compressing data to improve the speed and the efficiency of communication. So there are three major functions of the presentation layer. We have translating, encryption and decryption, and then we have compression and decompression. So translating. So translating simply means that the presentation layer translates from one syntax to another. So it can translate from the ASCII code to the EBCDIC. It shall make sure that the application layer can be able to read the data that is going to come. Then we have encryption and decryption. So the presentation layer can encrypt data to protect it from unauthorized access during transmission, and decrypt data to make it visible to the receiving device. So when you are transmitting, you are transferring data from one device to another. The layer that is in charge of encryption and decryption is the presentation layer. So the goal of the presentation layer is, let's say from the server now you want to transfer data to the client. The presentation layer on the server side would encrypt that data, you understand, to ensure that it is secure during transmission. And then when it gets to the client side, the presentation layer on the client side will now decrypt the data to ensure that the user can be able to read and understand the data that is being transferred. Then we have the next one, which is the compression and decompression. The presentation layer can compress data to improve the speed and efficiency of communication, and decompress the data to make it readable to the receiving device. Again, let's look at it from the server and the client side. So from the server side, right, the presentation layer is in charge of compressing this data. Now the data can become smaller and become faster when it comes to transmission. To improve the speed of transmission, the presentation layer would compress the data in question. Then by the time it's going to the client side, the presentation layer in the client side will now decompress data. Why? So that it can make it readable for the receiving device. So the sender device will compress data, while the receiving device will decompress data to make it readable. Then we have the session layer. So what is the session layer about? The session layer, which is layer 5, is responsible for opening and closing communication between two devices. It manages the duration of this communication and it is referred to as a session. So basically, you heard about people saying a session, my session must close. So when two devices want to communicate with one another, there's a layer that's in charge of keeping that communication door open. You understand? So that is the goal of the layer. The goal of layer 5 is to keep the communication open in the sense that if the two until when the two devices are done communicating to each other before the communication session can close. So the goal of this layer is to manage the duration of this communication, ensuring it remains open long enough to transfer all the exchange data before promptly closing it to avoid wasting resources. So as in the session layer basically handles keeping the communication open during the time of when the data is being transferred from the sending device to the receiving device. And once that window is done, once the data is done being transferred, the next thing is that the session layer closes that session to prevent wasting of resources. Then um also, the session layer synchronizes data transfer by implementing checkpoints. For example, in the transfer of 100 MB file, the session layer might establish checkpoint for every 5 MB. In the event of a disconnection or a crash after 52 MB that has been transferred, the session can resume from the last checkpoint, requiring the transfer of only additional 50 MB of data without the checkpoint. The entire transfer would need to restart from the beginning. Alright, so let's explain. Let's say for example now the sending device wants to send 100 MB of file to the receiving device. So the session layer implements something called checkpoints. What exactly is checkpoint? I don't know whether you've played all these games like Game of no God of War, where you can save your what they call those things. Then you can save your progress, right? So there's a place where you have to go to save your progress. So that when you come back, you don't have to start from the beginning. You start from your last save progress. Alright, so let me explain how this relates to our session. So the session layer, what it does is that it implements checkpoints. So if you are sending 100 MB of data and implements checkpoint for every 5 MB of data. So let's say for example now the first five has entered, it keeps it as one checkpoint one, the next five checkpoint two, the next five checkpoint three. So in the case of when there's a disconnection, let's say you finish you've been sending the data and all of a sudden at 22 MB the connection was broken off. Let's say you lost connection, your internet, your data plan finished, right? Or there was a crash somewhere. The checkpoint holds in fact that the last point of this data was 50 because I'm saying every five this thing was 50. Now by the time you come back, by the time you reconnect back, all it has to do is to send the remaining 50 MB of data. You just have to start from the beginning and send the 100 MB of data from the beginning. Now megabyte is looking like a small size, but like when it comes to data transfer and it's like large size, this will save you a lot. You understand? I hope this is clear. I hope this is clear. Alright, so let's go to the next one. We have layer 4, which is the transport layer. The transport layer is responsible for end-to-end communication between two devices. This involves taking data from the session layer and breaking down into chunks known as segments and forwarding these segments to the layer 3. So what's the as layer 4 implies transport. What's it doing? It takes the data from the session layer. um and break it down into smaller segments, into chunks, and then forward the segments to the layer 3. On the receiving device, the transport layer assume the responsibility of assembling the segments into data that the session layer can process. Okay, explanation. On the client side now, let's say it's sending information from, okay, no, let's do the yeah, on the client side, correct. It's sending information from the application layer, it passes the application layer, it goes presentation layer, from presentation layer, it goes to session layer. Once it gets to transport layer, that is layer 4. Layer 4 responsibility is to take that data and break it into segments. So it's breaking it into segments. So when it breaks it into segments, it now send those segments to the layer 3. That's the network layer. While on the client side, right, it picks those segments from layer 3, that is the network layer, and it assembles the segments to turn it into data that the layer 5, which is the section layer, can process. Hope I didn't lose you. Hope I've not lost you. Alright, let's go. The transport layer also manages flow control, flow control and error control. So flow control determines the ideal transmission speed and preventing a fast sender from overwhelming a slower receiver. So basically, what is flow control? Flow control basically is ensuring that, let's say I'm sending the information at 100 megabytes per second, and my own and the person that is receiving can only collect at 20 megabytes per second. The flow control is to ensure that the 100 megabytes per second sender does not overwhelm the 20 megabyte sender. Do you understand? So it will reduce the data that is coming in, so that the 20 megabytes data megabytes per data receiver would be able to process data small small. Then simultaneously error control implemented on the receiving end ensure the completeness of the received data and request retransmission if any part is missing. So basically, what it means is that the error control is, if for example I'm sending data from um let's say from sender device now to the receiving device, the transport layer ensures that whatever data that is being sent is complete, you get, so that if any data is missing or if any part of the data is corrupted, it can request for a retransmission, you get. So the transport layer protocol encompasses of the transmission control protocol, which is TCP and the UDP. Remember in the last class we talked about TCP and UDP, right? So you can go over it and understand TCP and UDP. So what are the main functions of the transport layer? Number one, segmentation. That is when it comes to breaking down the data into segments. Then we have reassembly, when you gather the segments and turn it into data for the session layer to process. Then we have the flow control, which is to prevent a fast sender from overwhelming the slow receiver. And then we have error control, which is to ensure that the data that is being sent is completed. And if the data is not completed or there's a missing part, it can request for retransmission. Alright, let's go to the next layer. So we have the network layer, which is layer 3. Alright, so what does it do? Layer 3 is responsible for facilitating data transfer between two different networks or devices. Okay, if the two communicating devices are on the same network, the network layer is not needed. Within its function, the network layer segments data from the transport layer into smaller units referred to as packets on the sender device and reassemble these packets on the receiving device. Additionally, the network layer role involves finding the best physical path for data to reach its destination, and it is known as a process called routing. So what is the network layer? So the network layer goal is to transfer data between two different network or devices. So it's in this network layer that you have to see things like, okay, this is where the IP addresses come into play. So what the network layer does is that it will break down the segment that it has gotten from the transport layer into smaller units called packets. So that packet contains things like the sender device IP address and the receiving device IP address. So the network layer is in charge of um knowing, okay, this is the destination IP address, this is the receiving IP address. I'm going to send this data to this IP address, right? And also it's the goal, another responsibility of the network layer is to find the best physical path for the data to reach its destination. So and this is known as routing. So routing simply means that you need to find the best physical route. So when transmitting data, you can pass through different routes because we are using the internet and the internet has different routes of communication. But the goal of the network layer is to find the best path, and the best path is the shortest and the fewest path. You understand? So what exactly is the network layer responsible for? Number one, the network layer is responsible for breaking down the segments gotten from transport layer into smaller pieces, units called the packets. Now these packets contain the IP addresses of the sender device and the IP address of the receiving device. Then it's also responsible for finding the best possible path for which data should travel. So the network layer protocol encompasses the IP. So we have internet protocol, we have the internet control message protocol, we have the internet group message protocol, and we have the IPsec suite. So we can dive, I know that we looked at IPs, we looked at ICMPs, and we looked at IPsec in the last class. So you can dive deeper into understanding what these protocols are and how exactly it works in these layers. So the next one is the data link layer. So the data link layer shares similarities with the network layer, but its primary function is to facilitate data transfer between two devices within the network. It achieves this by taking packets from the network layer and dividing them into smaller units known as frames. Like the network layer, the data link layer is responsible for managing flow control and error control in intra-network communication. It ensures that data flows smoothly and errors are corrected, a role distinct from the um transport layer, which focuses on flow control and error control for inter-network communication. So basically, the data network, the data link layer breaks down the packets into frames, right? Please give me a minute. All right. So the data link the data link shares similarity with the network layer, right? But the primary function is to facilitate data transfer between same network. So what does it do? It takes the packets from the network layer and divide them into smaller units known as frames. Now this data link layer is responsible for managing flow control and error control in intra-network. So intra-network is more of same network within an organization, same network basically. So when you are saying intra is same network, while inter-network is different different networks basically. So if you look at it this way, the transport layer does flow control and error control for across different networks. When we are talking about within the same network, it is the layer 2, which is data link layer, that handles the flow control and the error control. So basically, that what's the responsibility of data link layer? It is to break down, or it turns the packets, or it breaks down the packets from the network layer into smaller units called frames, and it does flow control and error control for same network or intra-network communication. All right, so we are getting to the last layer, which is our physical layer. All right, so this layer encompasses the physical equipment involved in data transfer, usually cables and switches. So the physical layer is more of physical, as the name implies. So it's like like the physical thing that you can touch and see. So things like cables now. For example, we have cables like fiber optics cable, we have Ethernet cable, we have the coaxial cables. So these are cables that handles data transfer. You understand? And things like switches as well. It is also the layer where data is converted into bit streams, representing represented as ones and zeros. You understand? So this is where we have the bits, where we have zeros and ones, computer language, binary language, and stuff like that. Additionally, the physical layer of both device must establish a single conversion to distinguish between ones and zeros on both ends. So the sending device and the receiving device must have a a single point of conversion to distinguish, okay, zero means this and one means this when it comes to communication. These are the seven layers of the OSI model, and they are basic this thing. Seven layers of OSI model and the basic introduction into them. So there are different protocols that operate in each of these layers, right? Your goal is to read, understand deeper, dive deeper into the OSI model and understand it well. So let's go to the next one. Okay, yeah, significance of the OSI model. Understanding the OSI model is crucial for cybersecurity professionals to diagnose network issues and vulnerabilities. It It aids in selecting appropriate security measures for each layer, such as firewall for the networking layer and encryption for the presentation layer. So when you understand the OSI model, you know what security measure you want to use for each layer, you understand, for each of the OSI layer. Your network security policies can be designed to control data flow and access at different layers. So when you understand the OSI model, you can create network policies that control data flow in different, like, and data access basically for different layers. Then cybersecurity experts use OSI model to identify potential threats and vulnerabilities at specific layers. So when you understand the different OSI model, different layers of OSI model, you can now understand that, okay, this is a possible cyber threat, this is a possible potential threat for this layer, and then look for how to combat it, how to mitigate these threats. Then intrusion detection and prevention system are designed based on the OSI layer awareness to monitor network traffic. So alright, let's move to the next one. We have the network topology. Network topology. So what exactly is the network topology? Network topology refers to the physical or logical layout of a computer network. So network topology is um how how computer devices, how computer cables, how the nodes, talked about nodes in one of our classes, how the endpoints, the intermediate devices, how the cables, how all these things are physically connected or logically connected. You understand? So it refers to how devices or nodes are connected and how data is transmitted within that network. So network topology influences network performance, the stability of the network, the reliability of the network, and the security of the network. So network topology is very important because it's basically how the network is laid out basically, and it influence how fast the network is going to be, how fast the communication with each devices on the network, how scalable it is. So if you want to add more devices to this network, is it possible? Is it possible for you to add more devices to the network? How reliable it is? What is the fail points? Like how long will it, like if something spoils on this network, does that mean that everything in this network is down? Does that mean that we're not able to communicate with each other on this network? So that is reliability. And then security. How secured is this, right? How secured is this particular network topology? So let's dive in. So types of network topology. We have point to point, we have bus topology, we have star topology, we have ring topology, we have mesh topology, we have tree topology. Also, we have hybrid. So basically, let me explain everything, then I will just talk a bit about hybrid. All right. So let's go into point to point topology. So what exactly is point to point topology? Point to point network consists of precisely two hosts such as computers or switches or router directly connected to each other using a single cable. Typically, one host sending end is connected to the receiving end of the other host and vice versa. So it basically consists of two distinct devices, either two computers, two switches, two routers, two devices connected by a single cable. So computer A is connected to computer B with a single cable. So computer A would probably take on the sending side while computer B takes on the receiving end, the receiving side, right? So point to point is basically one line of communication between two devices. You get. Now we have something called the bus topology. So in a bus topology, all devices are connected to a single central cable that is known as the bus. So if you look at the image that we have here, we have a single line of cable, right? And we have different devices connected to that single line of cable. Data is transmitted along the cable and each device on the network receives the data. So if you want to transfer from this device point A device to point D device, the data is going to transfer along this table. So this other device will get it, this other device will get it before it gets to this particular device that you want to transfer to. So however, the bus topology faces issues when when multiple hosts send data simultaneously. So if all these hosts like to be sending data at the same time, there's going to be conflict, there's going to be issues, right? To address this, what happens? It employs the CSMA/CD technology, and this CSMA/CD stands for Carrier Sense Multiple Access with Collision Detection. Basically, it is a network protocol used in Ethernet network to manage how devices share a common communication medium. So basically, this technology is a protocol for Ethernet networks, that is for cables and the rest. It basically manages how devices would share a common medium, communication medium. And the communication medium here is this single central cable, is the communication medium. So when there's an issue where multiple hosts sends data simultaneously, it makes use of this technology, right? This CSMA/CD technology to determine or to manage how these five devices on this network can share this one central cable. All right. So or it designates one host as a bus master to resolve the conflict. So it can pick one host here that okay, this host will be the bus master and that host will help to resolve the conflict. It is a straightforward network layout where the failure of one device does not impact the others. So for example, with these 5 devices that are connected to this bus now, if device A fails now, nothing is going to happen. Everybody's going to keep on communicating with one another. You understand? You just need to take out device A, repair device A, and bring back device A. You get? But then, if the shared communication line fails, the network is disrupted. So if this line now fails now, the network is disrupted and you have to now go and replace the shared communication line. At each end of the shared channel, there is a line terminator. That is this thing here, a line terminator. Data is transmitted in one direction and it reaches the far end. And when it reaches the far end, the terminator removes it from the line so that to prevent reflection. But let's say now device A sends data to let's say device D now. After it flows and gets to this line, this ending of the line, the terminator removes the data from the line, or else it will go back, it will bounce back and flow again to the opposite end, which can cause stress and can cause disruption of data. You understand? So that is the reason why we have terminators. Then we have star topology. Star topology looks like a star as the name implies. A star topology features a central hub. So a central hub, a central switch, a central router that connects all the devices together. So this device is connected directly to the hub. This one is connected directly to the hub. Because they're not connected to each other, they're connected directly to the hub. So they are having a point to point connection with each other. A point to point connection with the hub. So the hub has a point to point connection with device A, with device B, device C, device E, device F, sorry, device D, device E, device F, basically. So data flows through the hub and if one device fail, it doesn't affect the other devices exactly. So if one device fail now, if device D fails now, nothing is going to happen. Everybody will communicate. All they need to do is to remove the cable that has to do with device D. You get, and everybody will keep on communicating to one another. But if the hub fails, connectivity to all the hosts of all hosts to the other host fails. So basically if if the hub in the middle fails, right, none of these devices will be able to speak to each other again because it has a one point of failure. One point of failure. So if this hub fails now, that's the end. We need to get another hub to communicate. And the star topology is not expensive as to connect one more host, only one cable is required and the configuration is simple. Let's say for example now we have just 7. I want to connect like 10 more. So I want to connect 3 more. All we need to do is to bring a cable as long as the ports on the hub allows it, or bring a cable, plug the cable and plug the computer or plug the system that we want to connect to this network, and then it's connected. So it's not expensive, doesn't require a lot to add, so it's scalable. You understand? Though we talked about scalability, it is scalable. So we have the ring. In ring topology, each host sorry in ring topology, each host machine connects to exactly 2 other machines, forming a circular network structure. So A is connected to D and B connected to A and C. So basically, so that everything will become round. When one host attempts to communicate or send a message to a host that is not adjacent to it, the data travels through all the intermediate hosts to sorry, the data troubleshoot all the intermediate hosts. So let's say for example A wants to send information to B, sorry, to D or to C, right, rather. So it is going to pass through B and then get to C. You understand? It's going to pass through B and get to C. You get? So it's going to pass through B and get to C. So that's what it's talking about. That if you want to communicate with a host that is not directly beside you, you understand, you have to pass through. And then also if the communication on this um network is unidirectional, that means just moves only in one direction. Even if A is connected directly to D and he wants to talk to D, he's going to have to pass through B and C to be able to talk to D. You understand? That is if it is unidirectional, that's if it's just one direction. But if it's like bidirectional, that means you can go clockwise and anti-clockwise, then you can talk to either of the ones beside it. So to add one more host to the existing structure, the administrator needs only one the administration may only require one additional cable. So all you need to do is to just add um one more cable. So you will connect from A, add another device here and then connect again. So that's basically just how, let me see. Okay, I can turn on a pen oh. Wow. Alright, so let's say you want to add another device. All you need to do is just add the device like this and then you just connect this one, connect to this one. Or that's also all you need to do when you want to add like a, what they call it, an extra device. So the failure of any host results in the failure of the entire ring. Therefore, every connection in the ring represents a potential point of failure, but it's relatively easy to troubleshoot. So basically, if for example um this this has an issue, the whole ring will stop working. You get, the whole ring will stop working. If that has an issue, the whole ring will stop working. This eraser. Don't erase all now. Basically. So this point can be a point once let's say this place has an issue, everything will stop working. You understand? But one thing about it is that it is easy to troubleshoot. It's easy to troubleshoot. So you can quickly identify that, oh, okay, is this cable that spoiled? All I need to do is to just change this cable. Oh, is this host that has issue? All I need to do is just remove this host and join these two together. You understand? And maybe make it a three ring system and all of that. So that's basically it. All right, let's go to the next one. We have the mesh. The mesh topology. For the mesh topology, every device connected to every device. So this device connected to this one, connected to this one, connected to this one, connected to this one. So every device is connected to every device, creating a highly fault-tolerant network with multiple data paths. So look at it this way. If since every device connected to every device, if this place has an issue, eh? If this place has an issue and these two want to communicate, they can still communicate with each other. They can communicate through passing through this link and then going up like this. You understand? Even though this one had an issue. Do you get what I'm saying? So if let's say this host is bad now, it's not going to cause any problem. You understand? Because this one can communicate with this, can communicate with this one, can communicate with this one without the need for this particular host. So that's why they say it's a highly fault tolerant system network. So it means that whatever happens, you understand, it can stand strong. But however, the approach is complex and expensive. So it requires a lot of cabling. You understand? It requires a lot of cabling and it poses challenge in network administration. So when you think about how the implementation of this stuff, the implementation is difficult. You understand? It requires a lot of thinking, requires a lot of calculations and everything like that. So that is one thing. So one thing or one way of um wireless communication has made it a lot easier to implement mesh topology. You get? Alright, so let's go to the next one. Alright, so we have the tree topology. So the tree topology often referred to as hierarchical um topology or tree network. Is a combination of two or more different types of network topology to form a larger and more complex structure. So the structure resembles a tree with a root node at the top. So this is the root node at the top, and the branches stemming from the roots. So we have a branch here and a branch here, and the leaves, that's this ones, and the leaves at the ends of the branch. So basically what is happening there is hierarchical, right? So it's like a tree. So you have the roots, it breaks up into different distribution layer, it breaks up again to access layers and stuff like that. So basically it's more of like um it breaks up into small layer. The problem with this is that if there's an issue at the root, the whole if there's an issue at the root, if there's an issue here, the whole network becomes faulty. Yeah. It is commonly used in larger organization to offer balance and scalability. So you can be able to add, you can add another layer here, you can add another layer here, and this layer can have its own branches. One, two, three. Look at, so it is scalable. It's scalable and it's also reliable. If there's an issue with this ones here, you can continue. But if there's an issue with this entire one, let me clear this stuff so that it's not be looking the same. If there's an issue with this entire connection, you understand? Everything will still be working, every other part will still be working fine. You understand? So it's basically used by larger organization to offer scalability and reliability. And then there's another type of topology called the hybrid, which is a mixture of both the of any of these ones that we have here, of any ones. Yes, so it can be a mixture of burst and star, can be a mixture of star and ring, can be a mixture of mesh and ring. It all depends on the network administrator discretion, you understand. So the hybrid technology is a mixture of any of the network topologies, you get. So it depends on the administrators what they call jurisdiction, you get. So basically this is all about the network topologies. So why is network topology important? Number one, for security. Network topology impacts security. For example, star topology offers better security as each device connects directly to the central hub, making it more challenging for unauthorized access, in contrast to ring and bus topology. So when we talked about star topology in the sense that every device is connected to a hub. But if we look at ring topology, every device connected to one another. Let's go to ring topology. So for example, if this device has a virus now, it will infect when this one pass a data. Let's say A wants to connect to C, but this one has a virus. So it now pass the data here, and the data will now pass here. So as data is passing here, it's passing with its virus. So when you have ring topology, things like worms can spread very fast with ring topology, because whatever information is passing through another device. That's when it comes to security. That's when it comes to security. So resilience. Certain topology like merge and hybrid are more resilient in failures and ensure network continuity even when devices fail. Yes, very important. So when it comes to resilience, how when there's a failure, how does this network topology react, right? Does it have one point of failure? If one thing fails, does it mean that everything has failed? Do you get that kind of thing? Does it have one point of failure? And it's important to be able to have like backup systems, you understand? And resilient devices or resilient networks are very, very important when it comes to cybersecurity. You don't want your availability to be having issues. You don't want that when you need to access something, you can't access it because of the type of network topology that you are making use of. There's scalability. The choice of topology affects scalability. When planning for growth, the choosing topology should allow for easy expansion. So if you know that with time you want to increase the topology, you want to increase the size of this network, you have to make sure that the topology that you are selecting allows easy expansion, and the expansion does not cost a lot or requires a lot of administrative knowledge. Then we have performance. Network topology affects data transfer speed, while well-designed topology minimizes data bottleneck and ensure efficient communication. So performance of data, performance of data transfer. So if you are whatever network topology you are using affects the speed at which your data is transferred at. And another thing is that if your network topology is not good enough, you can have the process where a lot of data are being sent, and it can cause overwhelming of the network ability. You understand? So the last one is management. So different topology requires various level of management. This can impact the security team's workload and the ease of monitoring and maintaining the network security. So depending on the kind of network topology that you are making use of, you can learn how to manage, because each topology has different ways of management, right? So depending on the topology you're working with, you can be able to learn how to manage that topology. And some topologies are easier to manage than the others, you understand? So it can be more work for you, can be less work for you. It all depends. So this is why network topology is important. In a grand scale, it might be looking, oh, small, 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 small. But like in an organization, you need to know your network topology so I can know how I can manage some resources. You understand? So this topic of discussion, how do the different layer of OSI model work together to communicate data over a network? So just think about it. We talked about the OSI layer, we talked about the application layer, presentation layer, session layer, what's the next one after session layer? Session layer, we have the transport layer, we have the network layer, we have data link layer, and we have the physical layer. So we talked about each of these layers. So how do you think that this layer can work together to communicate data over a network? So just think about it logically, like okay, from I want to send information from device A to device D. So how does this communication work with the network layer? Remember that all the all the layers will happen on network D from the sender. Let's say the sender will start from 7 to 1, while the receiver will start from 1 to 7. You understand? And then how can the OSI model be used to troubleshoot network problems? So we talked about how learning the OSI model is very important because it can help you troubleshoot issues that are going on with the network. So how do you think that the OSI model can do that? Then what are the types of network topology? So you think about it that, oh, what are the types of network topologies that we have, and how does network topology affect network performance and reliability? Yes. All right. So if you have any questions, please what they call it, please reach out, write your question, enough pen, write your questions here, please. And then what are the advantages and disadvantages of each type of network topology? We talk about the different network topology from both from start, point to point, mesh, ring, everything. So your goal is to write the advantage and disadvantage of each network topology. Each network topology has advantage and disadvantage, you understand? So what are they? Then what are the some examples of real world networks that use different types of network topology? So you need to look for real life example. Okay, what topology does the internet make use of? You understand? What topology can an organization make use of? A small organization, what topology can they make use of? You understand? So the goal is to understand the what topology and how it works in the real world, and send your assignments to this link. Alright, I hope this has been a very insightful session. Hope you've understood the basic of these things, and have a very wonderful and productive day. Bye.